So this bubbler is made according to Paul Pantone's class handout. 4 inches diameter times pi would be the distance from the top to somewhere in between these two marks. So that's diameter times pi is the amount of area above fluid level, and then you want 20 to 25% the total to be where you keep your fuel level for optimal performance. You can see I was getting a lot of foam there. I have a 1/4 inch inner or 1/4 inch copper pipe in here. I'm not sure if that's inner or outer diameter. I think it's inner diameter for copper tubing. And then I got these 1/2 inch bulkheads. So I have a, I don't know if you can see it, there's a compression fitting, 1/4 inch copper pipe compression fitting to 1/2 inch NPT thread. And I have a 1/2 inch to 3/8 inch bushing here with a 3/8 inch vacuum relief valve from Grainger. Notice as I tighten this down to create more vacuum in here, it started running slower, but the longer, now I don't have a very good reactor setup here. I need to redo my reactor. Not getting a good reaction, not getting good magnetic signature on my rod. If I was getting a good reaction, it would run a lot smoother. It would start on one pole. Notice my fresh air intake is totally closed, so all the air I'm getting is coming through this 1/4 inch pipe. Can control the throttle with the stock carburetor. You know, there's a choke up here which is fully open. I have the fresh air choked here, but the carburetor's choke is full open, and then you can adjust the throttle with the stock throttle control. So it's controlling the full intake. So, you know, I could add air here, which would control my fuel air ratio, but then the butterfly valve beyond that in the carburetor is going to control the amount of fuel air mix going into the engine for combustion. So that's controlling the throttle. So with the better reactor design, this should run a lot better. As it is now, it has to heat up before I can close off this fresh air intake. So if it's totally cold and I have the fuel level up here, then I have to add fresh air there. But as it runs and gets warm, I can slowly close off that fresh air choke there. And as it gets even hotter and hotter, I can really tighten down this vacuum valve all the way to where that nut is. And then when it finally runs down and stops, because the fuel level gets really low, then you hear this relief valve just go as the vacuum, as the amount of suction reduces and the valve finally closes. You can see when it's running, this tube just gets sucked closed. So it's really, there's not much air getting in there, but still it's running full on. I haven't done any fuel economy tests with this new reactor. It's just kind of a pain to set up the stock fuel system. I mean, it's not that much of a pain, but I'll do another test after I replace this reactor. The first reactor I had on here, I tested, and I got way better, lower emissions with the reactor, and I got a 30% improved efficiency, but I have done better than that. So anyway, just wanted to really make this video to show this new bubbler I made according to Paul Pantone's plans that he provides in his student material.